Hi everyone, my name is Bouliane. Today I'm going to talk about how virtual machines access our metadata service. The first thing we will see is what is a metadata service. I will then speak about how things are plumbed together using openvswitch, and then I will show you the details of the OpenFlow rules that form this datapath. In addition, I added code samples to show you how these rules can be added programmatically via go-openvswitch. But first, DigitalOcean. We're a cloud hosting company running more than 20,000 hypervisors, over 13 data centers. On each of these hypervisors, we're running openvswitch to build our virtual network. This is through this virtual network that the VMs access our metadata service. So what is this metadata service? It's simply an HTTP server listening on port 80, and just like at many other cloud providers, accessible via the special IP address 169.254.169.254. The service is used to allow virtual machines to access metadata about themselves and to enable programs such as Cloud Init to configure the virtual machines at creation time. Via this service, you can get information related to the virtual machine's property, like hostname, public keys, region, and also about the network interfaces, the floating IPs, the DNS, etc. As you can imagine, one very important role for the service is to determine who's asking for the information, because it needs to return the data that belongs to the right user. We will see later how the metadata learns that information and how it uses it. But for now, let's see how everything is plumbed together via openvswitch. Each virtual machine has a network tap interface plugged into the switch. The metadata service is accessible via the meta0 interface. It's an openvswitch internal port also plugged into the switch that makes possible communication with services running on the host. The metadata service runs on the host and listen on the special IP address I mentioned earlier. On the host, we also have an IP rule that filters all packets originating from that IP address to make sure they are sent via the meta0 interface. And that's basically how the packets move from the VMs to the meta service. The first thing the VM needs to learn is the MAC address of the metadata service. On the other side, same thing, the host needs to learn the MAC address of the virtual machines. There are many ways to achieve this, but to make things simple, we decided to have openvswitch to answer the ARP request. You might have realized that the IP address the metadata service is ARPing for is not the VM IP, and it's right. I'll show you later that we also have network address translation playing a role in our setup. Now let's see what are the flows that we have to answer ARP requests on both sides. Here is the ARP flow used to answer ARP requests from the VM. It's not super clear what it's doing. When I have to work directly with flows, I usually highlight the fields and open the Wikipedia page to remember what are the fields for a certain packet type and what they mean. But if I show you the corresponding code with go-openvswitch, it's way easier to see what we are matching on and what are the actions. Here, we make sure that the ARP request is specific. The ARP request is from a specific VM, and then we are modifying the ARP request, changing it so it becomes an ARP response, and we're sending it back. And here we have the flow to respond to the ARP request sent by the host. We're basically doing the same thing. Let me show you the code. We're matching some fields to make sure the packet is coming from the metadata service and checking the address it's asking for belongs to which VM. We then modify the ARP request so it becomes an ARP response, and we're sending it back. Here again, we have the big picture. We see the ARP request and we see the ARP response sent by openvswitch. I talked at the beginning that the metadata service needs to learn who is asking for the data. The way we proceed with that is we embed the OpenFlow part into the IP address. The metadata service then looks up into an internal map to find the corresponding VM unique ID. Here we can see the network address translation being applied to the traffic. Let's see the different flows that we have to accomplish this. Here we have the flow that translates the source address of the packets from the VM. You can see that we are matching on some fields to make sure that the destination corresponds to the metadata service. We then commit the packet to the connection tracking table. Every packet matching this flow will have its source IP translated. And now let's see the opposite direction. Here we are making sure the packets are coming from the metadata service, and we check the destination IP belongs to which VM. We then send the packet to the connection tracking table where the address translation will happen. We have a second flow that matches on the contract state and then validates the destination of the packet to send it to the virtual machine it belongs to. Here we have the big picture of the all HTTP requests. You can imagine the request coming from the VM being natted and arriving at the metadata service. And then the response is being natted back. And it completes the whole transaction. And in conclusion, we saw what is a metadata service and what it can be used for. We also saw how we leverage OpenvSwitch to build the data path needed to access the metadata service. And in bonus, some code sample to show you how to programmatically create these flows with the library OpenvSwitch. Thank you.
All right. Let's thank our speaker for the talk and the work behind it. If Nick is here and you'd like to come on voice and video, then we can discuss the talk a little bit. So Nick, if we're lucky, we'll get some questions. But this late in the conference and in the afternoon, I think people are getting a little bit sleepy and a little bit tired. So that might not happen. Do you have any thoughts you'd like to share while we're waiting to see if we get some?
I guess first, thanks to you and all the organizer for the conference. I've been attending for a couple of years, and every time it's awesome to learn so many new stuff. Everything's going on in OpenvSwitch. So thanks to you.
Oh, you're very welcome. I'm glad that it's been good. And we do have a question. So Frode Nordahl asks, providing metadata service appears to be a networking problem that multiple virtual machine cloud management systems have. Have you considered discussing with the community how this could be added to OVN, for example?
Oh, yeah, that's a good question. No, I haven't looked into OVN, how it could be done. I guess it's a great point. I should definitively look into this.
Well, it's always good when we can try to use standards and avoid duplicating work. So it's always a little harder to coordinate with people, but sometimes it pays off. So that might be the only question we're going to get. If you have any further thoughts, for example, on future work, you're welcome to share them. But otherwise, we'll move on to our final talk.
Yeah, well, on OpenvSwitch in general, we are interested into looking into OVN for sure, but also into the user space AFXDP development being done. So there is a lot of exciting stuff for us. And that might help us also being in a position to contribute if everything in user space allows us to follow more closely the latest version and also participate. So exciting stuff coming up.
So we have another question, this one from Valentine, who asks, are you running only pure OVS or I'm not quite sure how to interpret the question. Perhaps there Perhaps Valentine is asking whether you're running other DPDK apps as well?
No, so we are using the like OVS with the kernel datapath. We don't use DPDK, but we are interested, and we started to look at OVS user space with AFXDP.
All right, thank you very much. So with that, we should move on to our final talk.